Welcome to our fact channel. Our channel has well-known, little-known, and unknown facts. Today we will discuss facts about planet Uranus. Let's start. Uranus is unique among the planets in our solar system because it rotates on its side, with its axis tilted almost 90 degrees relative to its orbit around the Sun. This unusual tilt is thought to have been caused by a collision with a massive object early in its history. Like Saturn, Uranus has a ring system, although it is much fainter and less prominent. The rings were first discovered in 1977 when Uranus passed in front of a star and caused the star's light to blink on and off, revealing the presence of narrow rings around the planet. Uranus is classified as an ice giant, a type of giant planet composed mainly of water, ammonia, and methane ices in its outer layers. Its atmosphere also contains traces of hydrogen and helium, similar to Jupiter and Saturn, but its composition differs significantly from the gas giants. The only spacecraft to have visited Uranus up close is NASA's Voyager 2 probe, which flew by the planet in 1986. During its brief encounter, Voyager 2 captured detailed images of Uranus and its moons, providing valuable data that revolutionized our understanding of this distant ice giant. Like Jupiter's Great Red Spot, Uranus once had a dark spot in its atmosphere known as the Great Dark Spot. This feature, which was observed by Voyager 2 during its flyby in 1986, was a massive storm system that persisted for several months before dissipating. However, unlike Jupiter's spot, Uranus' spot was short-lived and has since disappeared. Uranus has a total of 27 known moons, each with its own unique characteristics and features. The largest moons, known as the major moons, are Miranda, Ariel, Umbriel, Titania, and Oberon, named after characters from the works of William Shakespeare and Alexander Pope. The smallest moons are much smaller and were discovered more recently. Uranus' magnetic field is tilted at an angle of about 60 degrees relative to its rotational axis, making it one of the most tilted magnetic fields among the planets in our solar system. This unusual configuration is thought to result from the planet's unique orientation and internal dynamics. Uranus is one of the coldest planets in our solar system, with temperatures dipping as low as -224 degrees Celsius (-371 degrees Fahrenheit) in its upper atmosphere. The planet is also known for its fierce winds, which can reach speeds of up to 900 kilometers per hour, 560 miles per hour in the upper atmosphere. Uranus' atmosphere contains a significant amount of methane, which gives the planet its distinctive blue-green coloration. When sunlight interacts with methane molecules in the atmosphere, it absorbs red light and reflects blue and green light, resulting in the planet's unique appearance. Despite its massive size, Uranus has a surprisingly rapid rotation, completing one full rotation on its axis in just 17.24 hours. This rapid rotation contributes to the planet's flattened shape and may also play a role in its complex atmospheric dynamics. Uranus is orbited by a system of rings and moons which interact with the planet's gravitational field and influence its overall dynamics. The rings are composed of dust, rock, and ice particles, while the moons vary in size and composition, ranging from small, irregularly shaped bodies to larger, more geologically diverse worlds. Despite decades of study, much about Uranus' interior remains a mystery. Scientists believe that the planet has a rocky core surrounded by a thick mantle of water, ammonia, and methane ices, but the exact composition and structure of its interior layers are still not well understood. Uranus was the first planet to be discovered using a telescope. It was first observed by the astronomer William Herschel on March 13, 1781, while he was conducting a systematic survey of the night sky. Herschel initially thought he had discovered a comet, but later realized that he had found a new planet. Uranus is one of only 2 planets in our solar system that rotates in a retrograde direction, meaning it rotates from east to west rather than west to east like most other planets. This unique rotation is thought to be the result of a catastrophic collision early in the planet's history. Uranus experiences extreme variations in its weather patterns, with powerful storms, cloud formations, and atmospheric phenomena occurring throughout its atmosphere. The planet's unusual tilt and rapid rotation contribute to its dynamic and ever-changing weather systems. Due to its extreme axial tilt, Uranus experiences extreme seasonal changes as it orbits the Sun. Each pole is alternately pointed toward or away from the Sun, leading to long periods of daylight and darkness, as well as dramatic changes in temperature and weather conditions. Uranus has a unique magnetosphere that differs significantly from those of the other planets in our solar system. Its magnetic field is highly asymmetrical and lopsided, likely due to its tilted rotation and unusual internal dynamics. The magnetosphere also interacts with the solar wind in complex ways, shaping the planet's magnetosphere and auroras. The Voyager 2 spacecraft made numerous pioneering discoveries during its flyby of Uranus in 1986, including the first detailed images of the planet's atmosphere, rings, and moons. These discoveries revolutionized our understanding of Uranus and paved the way for future exploration of the outer solar system. Uranus emits a surprisingly low amount of thermal radiation compared to other gas giants in our solar system, indicating that it has a relatively cool interior. This low thermal emission suggests that Uranus may have less internal heat and energy than Jupiter, Saturn, and Neptune. Uranus' atmosphere is composed mainly of hydrogen and helium, similar to the gas giants Jupiter and Saturn. However, it also contains significant amounts of methane, which gives the planet its distinctive blue-green coloration. Other trace gases, such as ammonia and water vapor, are also present in smaller quantities. Uranus' magnetic field is highly dynamic and undergoes significant changes over time, including fluctuations in strength, orientation, and shape. These changes are thought to be driven by the planet's unique rotational dynamics and internal processes, which influence the behavior of its magnetic field and magnetosphere. The rings of Uranus were discovered in 1977 when astronomers observed the planet passing in front of a distant star. The star's light flickered as it passed through the rings, revealing the presence of 9 narrow rings made up of dark particles. Since then, more rings have been discovered, bringing the total to 13 known rings. Similar to Earth, Uranus has auroras, which are caused by the interaction between the solar wind and the planet's magnetic field. However, the auroras on Uranus are much fainter and less predictable due to its unusual magnetic field and tilt, making them challenging to observe and study. Uranus' extreme axial tilt of 98 degrees is thought to be the result of a massive collision with an Earth-sized object early in the planet's history. This collision may have also contributed to its unique rotation and the complex dynamics of its atmosphere and magnetic field. Uranus' atmosphere is composed of multiple cloud layers, with the uppermost layer consisting mainly of methane ice. Beneath this layer, there are clouds made of hydrogen sulfide and ammonia, creating a complex and dynamic atmospheric structure. Due to its extreme tilt, Uranus experiences some of the most extreme seasonal variations in the solar system. Each season on Uranus lasts about 21 Earth years, leading to prolonged periods of sunlight or darkness at the poles and dramatic changes in temperature and weather patterns. Uranus is the 7th planet from the Sun, orbiting at an average distance of about 2.87 billion kilometers, 1.78 billion miles. This vast distance makes it one of the most remote and least understood planets in our solar system, with many mysteries still awaiting discovery. Uranus is composed primarily of hydrogen and helium, with significant amounts of water, ammonia, and methane. These ices make up the bulk of the planet's mass, distinguishing it from the gas giants Jupiter and Saturn, which are composed mainly of hydrogen and helium. The pressure in Uranus' atmosphere increases with depth, reaching levels much higher than those on Earth. At the core, the pressure is estimated to be millions of times greater than atmospheric pressure at Earth's surface, leading to the formation of exotic materials like supersonic water and metallic hydrogen. Uranus has 27 known moons, each with unique features and characteristics. The 5 major moons Miranda, Ariel, Umbriel, Titania, and Oberon are the largest and most geologically active, with varied terrains that include canyons, craters, and ice volcanoes. Uranus holds the distinction of being the first planet discovered using a telescope. British astronomer William Herschel discovered it in 1781 while surveying the night sky, expanding our understanding of the solar system and adding a new member to the list of known planets. A year on Uranus, the time it takes to complete one orbit around the Sun, is equivalent to about 84 Earth years. This means that since its discovery in 1781, Uranus has completed only about 3 full orbits around the Sun. The blue-green color of Uranus is due to the presence of methane in its atmosphere. Methane absorbs red light from the Sun and reflects blue and green light, giving the planet its characteristic hue. This coloration is a defining feature of Uranus and distinguishes it from other planets in the solar system. Uranus has a mass about 14.5 times that of Earth, making it the 4th most massive planet in the solar system. Despite its large mass, Uranus has a relatively low density, indicating that it is composed mainly of lighter elements like hydrogen, helium, and ices, rather than rocky material. Because of its great distance from the Sun, Uranus moves very slowly across the sky from our perspective on Earth. It takes about 7 years for Uranus to move through each sign of the zodiac, making it one of the slowest moving planets visible to the naked eye. Uranus has a complex ring system composed of 13 distinct rings. These rings are much fainter and narrower than Saturn's rings, and they are made up of dark, rocky particles. The rings are thought to be relatively young and may have formed from the debris of shattered moons or other celestial bodies. Uranus' magnetic field is unusually tilted and offset from the planet's center. This asymmetry leads to a highly irregular magnetosphere, with complex interactions between the solar wind and the planet's magnetic field. These interactions create unique auroras and influence the behavior of the planet's atmosphere and moons. Uranus rotates in a retrograde direction, meaning it spins from east to west, opposite to most other planets in the solar system. This unusual rotation is thought to be the result of a massive collision that knocked the planet on its side early in its history, creating its extreme axial tilt and retrograde rotation. Uranus is often considered the coldest planet in the solar system, with temperatures in its upper atmosphere dropping to -224 degrees Celsius (-371 degrees Fahrenheit). These frigid temperatures are a result of the planet's great distance from the Sun and its low internal heat. Uranus is classified as an ice giant, a type of giant planet that contains more ices such as water, ammonia, and methane than gases like hydrogen and helium. This composition differentiates Uranus from the gas giants Jupiter and Saturn and gives it its distinctive blue-green color and unique atmospheric characteristics. Uranus has been observed since ancient times, but it was not recognized as a planet until its discovery by William Herschel in 1781. Early observations of Uranus were often mistaken for a star or comet due to its slow movement and dim appearance in the night sky. The discovery of Uranus played a crucial role in the discovery of Neptune. Astronomers noticed irregularities in Uranus' orbit that could not be explained by known gravitational forces, leading them to hypothesize the existence of another planet beyond Uranus. This hypothesis was confirmed with the discovery of Neptune in 1846. Uranus is known for its powerful winds, which can reach speeds of up to 900 kilometers per hour, 560 miles per hour in the upper atmosphere. These winds create dynamic weather patterns and contribute to the planet's complex and ever-changing atmospheric conditions. Unlike other giant planets, Uranus emits very little internal heat. This lack of heat may be due to an unusual formation process or the planet's tilted axis, which could have caused its heat to escape more rapidly into space. As a result, Uranus has the coldest atmosphere of any planet in the solar system. The atmosphere of Uranus is composed mainly of hydrogen and helium, with trace amounts of methane, water, and ammonia. The methane in the atmosphere absorbs red light, giving the planet its characteristic blue-green color. This atmospheric composition also contributes to the planet's unique weather patterns and cloud formations. Uranus' extreme axial tilt remains one of the great mysteries of the solar system. Scientists believe that a massive collision with another celestial body early in Uranus' history could have caused this tilt, but the exact nature and timing of the event are still unknown. Further study of Uranus' interior and history may provide answers. The moons of Uranus were discovered over a period of more than 200 years, beginning with Titania and Oberon in 1787. The most recent discoveries were made in the early 2000s, with the identification of several small, irregularly shaped moons. These moons vary in size, composition, and geological activity, providing a diverse array of targets for future exploration. The origin of Uranus rings is still a subject of scientific debate. Some theories suggest that the rings formed from the debris of moons that were shattered by collisions with other celestial bodies, while others propose that the rings are remnants of the material that formed Uranus itself. Further study of the rings' composition and dynamics may help resolve these questions. Uranus auroras are created by the interaction between the solar wind and the planet's magnetic field. Unlike the bright and dynamic auroras of Jupiter and Saturn, Uranus auroras are much fainter and more difficult to observe, making them a challenging but intriguing target for scientific study. Due to its extreme axial tilt, Uranus experiences unusual day and night cycles, with each pole experiencing 42 years of continuous daylight followed by 42 years of darkness. This extreme variation in sunlight and temperature has a significant impact on the planet's atmosphere and weather patterns. Uranus moons are among the most diverse in the solar system, with a wide range of geological features and compositions. Miranda, for example, has a highly varied surface with deep canyons and large cliffs, while Ariel and Titania show signs of past geological activity, including tectonics and possibly even cryovolcanism. Uranus has been the subject of scientific study since its discovery in 1781, with major contributions from telescopic observations and the Voyager 2 flyby in 1986. These studies have provided valuable insights into the planet's atmosphere, rings, moons, and magnetic field, but much about Uranus remains a mystery, awaiting future missions. Uranus' axial tilt has significant implications for the planet's climate, weather patterns, and magnetic field. This extreme tilt results in unique seasonal variations and complex atmospheric dynamics, making Uranus a fascinating subject for study and a key target for future space missions aimed at understanding the outer solar system. Uranus is named after the ancient Greek god of the sky, reflecting its position as a distant and mysterious object in the heavens. The discovery of Uranus expanded our understanding of the solar system and inspired further exploration of the outer planets, contributing to the development of modern astronomy and space science. Exploring Uranus presents significant challenges due to its great distance from Earth, extreme cold, and complex magnetic and atmospheric dynamics. Despite these challenges, future missions to Uranus could provide valuable insights into the formation and evolution of ice giants, as well as the broader processes shaping our solar system. The discovery and study of Uranus have had a profound impact on our models of the solar system, leading to new theories about planetary formation, migration, and the dynamics of ice giants. Uranus' unique characteristics continue to challenge and refine our understanding of the processes that shape planetary systems. The future of Uranus exploration holds great promise, with proposals for new missions to study the planet's atmosphere, rings, and moons in greater detail. These missions could provide critical data to answer long-standing questions about Uranus formation, internal structure, and the potential for habitability in its moon system. Studying Uranus is crucial for comparative planetology, as it provides a unique example of an ice giant with distinct differences from gas giants like Jupiter and Saturn. By comparing Uranus to other planets, scientists can gain insights into the diversity of planetary systems and the processes that govern their evolution. Uranus plays a key role in the dynamics of the outer solar system, influencing the orbits of other distant objects and contributing to our understanding of the region beyond Neptune. Studying Uranus helps scientists piece together the broader picture of the solar system's formation and the interactions between its various components. Despite advances in our understanding of Uranus, much about its interior remains a mystery. Scientists are particularly interested in the planet's core composition, the nature of its deep interior layers, and the processes driving its magnetic field and atmospheric dynamics. Future missions and studies aim to uncover these hidden aspects of Uranus. Uranus' atmosphere is a dynamic and complex system characterized by rapid winds, seasonal changes, and unique cloud formations. Studying the atmosphere provides insights into the behavior of ice giant planets and the processes that drive their weather patterns, contributing to a broader understanding of planetary atmospheres in general. Uranus has contributed significantly to the field of planetary science, offering a unique perspective on the diversity and complexity of planetary systems. By studying Uranus, scientists have gained valuable knowledge about the processes that shape ice giants, the interactions between planets and their moons, and the evolution of the solar system as a whole. The Voyager 2 flyby of Uranus in 1986 left a lasting legacy, providing the first detailed images and data of the planet and its moons. This mission revolutionized our understanding of Uranus and paved the way for future exploration, highlighting the importance of robotic missions in expanding our knowledge of the outer solar system. There is growing interest in future missions to Uranus, with proposals for orbiters, atmospheric probes, and landers to study the planet in greater detail. These missions aim to address key questions about Uranus' composition, climate, magnetic field, and potential for habitability, contributing to a comprehensive understanding of ice giants. Thank you for watching our video Interesting Facts about Uranus. Subscribe, put a like, and to new interesting facts.